Hey everyone, and welcome to The Explainer. Today, we're diving into something pretty huge. We're talking about Einstein, the universe, and a radical idea that suggests we might be getting the very nature of reality, well, completely wrong. So let me just throw this out there right at the start. For nearly 100 years, the smartest people on the planet have been on this singular, massive quest. But what if that whole quest, this search for a theory of everything, is actually based on a flawed idea about what we're even looking for?
To really get why that question is so important, we first have to look at where physics is right now. And a great way to think about it is like this magnificent, beautiful, but totally unfinished symphony.
Okay, so modern physics stands on two giant pillars. On one side, you've got Einstein's general relativity. It perfectly describes the big stuff, planets, galaxies, the smooth fabric of space-time. It's predictable, it's continuous. Then, on the other side, you've got quantum mechanics. This is the wild, bizarre, frankly weird world of the super small. Particles, probabilities, spooky forces. It's just strange. And here's the kicker. They are both unbelievably good at what they do. The problem? They just don't play well together. They fundamentally contradict each other. They can't both be the final word.
And that huge conflict set up what has become the holy grail of physics. This decades-long quest to find one single, unified theory of everything. It's the dream of one elegant set of rules that could explain both the entire cosmos and the tiniest quantum particle.
But what if trying to stitch these two theories together is the wrong approach entirely? What if the problem isn't the theories themselves, but our perspective on what they even represent?
The source material we're looking at today makes a really bold claim. It starts by saying Einstein was almost right. His theory of general relativity was a monumental leap, no doubt. It gave us this amazing equation where space-time and energy both have a role. But he stopped short. He didn't quite take the final step and say they were one single substance.
And that word, perspective, that is the absolute key to this whole thing. A perspective isn't the truth itself, right? It's just a specific viewpoint on that truth. It's one way of seeing something, not the thing itself.
And this leads us to the core argument, which is pretty disruptive. It's the idea that general relativity and quantum mechanics aren't reality itself. They are powerful, they are incredibly useful, but at the end of the day, they are limited human perspectives on that reality. Think of it like this. You can have a road map and a topographical map of the exact same mountain. Both are accurate. Both are useful for different things. But neither one of those maps is the mountain. The mistake, this idea argues, is that we've been spending all our energy trying to merge our two maps, instead of asking a much bigger question. What is the actual territory like?
And this brings us to a new, pretty mind-bending proposal for what that territory, what reality itself, might actually be.
I mean, that's the logical next question, isn't it? If our best theories are just viewpoints, what are we actually viewing? What is the fundamental thing that all of our physics is attempting to describe? The answer that's proposed is surprisingly simple. It suggests we stop thinking about a universe that's filled with a bunch of different things like space-time, particles, and energy. Instead, what if there's just one fundamental object that is reality and everything else we see is just a manifestation of it?
Okay, so how would this even work? Let's break it down. The single object that is reality is proposed to be just changing three-dimensional space. That's it. That's the foundation. And when this space twists or curls up in a really specific way on a tiny local level, well, our perspective sees that geometric behavior and we give it a name. We call it a particle.
This is really the key takeaway here. In this model, particles, matter, energy, they aren't little objects moving through some neutral container called space. They are what space is. A particle is just a name we give to a certain behavior of space itself. A wave of light isn't something traveling in space, it's a ripple of space. It's all the same thing, just behaving in different ways. So, if we accept this idea, even for a moment, what does it mean for the future of science? It calls for a pretty fundamental shift in how we search for answers. Now, it's super important to clarify this point. This idea does not mean we should abandon our work on general relativity and quantum mechanics. Not at all. Those perspectives are the most accurate maps of reality we have, and we absolutely need to keep refining them. This suggests a new strategy. Right now, the search is focused on one path, trying to unify our maps. The proposed new search is a two-pronged attack. Path 1 is to keep doing what we're doing, refine the map by improving our understanding of GR and QM. But at the same time, we would start Path 2, a brand new search to investigate the territory itself.
We'd start asking, what are the fundamental properties of this changing space? So the ultimate takeaway here isn't to stop what we're doing, but to broaden our search. It's a shift in focus. We continue the vital work of sharpening our human perspectives, while also starting a new parallel quest to understand the fundamental nature of the reality those perspectives are trying to capture.
And this leaves us with a final, fascinating question to chew on. For a century, we may have been trying to understand the entire universe by looking through the separate keyholes of general relativity and quantum mechanics. This new idea suggests it's time to stop trying to merge the keyholes and instead start working on how to open the door. What do you think we'll see when we finally do?